Go.
Hello!
Hello, Mr. Ari, are you alright?
Yeah.
Yeah. Okay, so we're talking about a continuous increasing digit. Okay, for numbers like this 1, 2, 3, single digit, 12, 23, 34. You see? So each number, okay, each digit in the number is 1 plus its previous one. So like 678, that's good. But not this one is not, right? This one is not, okay?
Well, can you do like 910?
Very good question. No.
But
Okay.
it's 910.
Yeah, I know, Bob. But that's a very good question, okay? But unfortunately, no, we don't count that. We only count the digit, okay? But this is a very nice point. And also for the number 0, we don't consider it a continuous increasing digit, okay? Let's just define it as a positive number, positive integer, x bigger than 0, okay? Where each digit of x is 1 plus each digit, okay? Each single digit is 1 plus its previous one, okay? So, how many of these kind of numbers within the from 0 to 100, okay? But we're saying we don't need to consider 0, so let's say from 1 to 100.
Last time I counted 17.
17, okay, so can you count it again?
So 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah, single digit, 2 digit now.
12, 23, 34, 45, 56, 67, 78, 89.
Okay, yeah, that's well done. So that's 9, 10, 11, 12, 13, 14, 15, 16, 17, well done. Okay.
Yay!
Okay, so how can we do this? If we want to find out all the numbers within the range, S from S to E inclusive, okay? From S to E inclusive. So what's your approach? How can we solve this kind of problem? How many ways can you solve it? Any idea? Breadth search. Depth search. Well done. And brute forcing. Yeah. Brute forcing. There are many. It depends on how you brute force. Yeah. The most stupid way of brute forcing is try every single number between S and E, and then checking each number if it's satisfies this, right? But it could take a long time, right? Yeah. Why is that? Because look, if the difference between the S and E is quite big, then you have to check quite a lot of cases, right? So that's very bad, right? Okay. So for the brute forcing and depth search, when we talk about the breadth search and brute forcing, we are talking about what? What we are talking about? What kind of problem? The
tree.
Here is the tree or
Graph.
graph. Yes, graph. So let's say if this number is 1, so what's the next one? What's the next node? What's 1? What's next? 2. Okay, so it's 12. Okay, what's next?
20.
No, 1. Okay, look, each digit. This is the first digit. Okay, then first digit.
123.
Yeah. You see, and then you see. So how many possibility of first digit? How many possibility? How many? When we pick the digit, let's start from picking the first digit. How many choice do we have for the picking?
9.
9 choice. Yeah. So we can have these 2, and then for 3, etc. till 9, right? Actually, 9 there is no edges coming out from 9, right? Because it's 9. 8 there's only one choice, which is 89. Okay. Yeah. The vertex. Each vertex is the number, right? So we can, let's say for breadth search, we can push. Remember a few days ago we talked about multi-source breadth search. We can push all these the first digit into the queue. So we have these 1, 2, 3, 4, 5 till 9, right? And then we take one number. Look, let's take one number. 1. I take the 1. First of all, I take it out and I check if it's within this range. If it's within this range, then I point it to the result, and I append the kid. Yeah, I append the kid, which is 1, 2, back to the count. Okay, so look, if this range is 10, up to 10, do we still have to push? Actually, no, if this range is, let's say, okay, if I take the 12 out, okay, I want to push the next kid is 123, right? But look, this is upper range. If it is up to 10, do I need to push this number again?
No.
Why is that?
Because it's
12 is already bigger, huh?
yeah.
So there's no point appending because it's still bigger, right? Yeah? Okay. So it makes sense, okay? Let's just quickly implement a breadth search, okay? Multi-source breadth search. In a breadth search, what kind of data structure are we using? Can we use to implement a breadth search? Define.
Q.
Find numbers. Yeah, well done. And then in Python, what's the Q?
DQ.
DQ, okay. Okay, let's say answer is a list. Q is a DQ. DQ offers the constant term in appending and popping in both sides, constant term. If we're using a list, the pop left, yeah, pop 0 is linear, it's not constant. That's why we use the DQ, by the way. So at the beginning, we want to, for I in range 1, we want to push the first key digit. So what should I do here? For I in range. For I in range 1.
I in range.
Wow, don't look at my notes. For I in range 1, we want to push the
1 to 9.
1 to 9. So 1 to the second parameter is what?
10.
10, yeah. And then Q dot append I, okay? And then Y, Q, we take a number, C equals Q dot pop left, right? And then we want to find out if it's in the range, right? S smaller than E, smaller than C, smaller than E. Then we do answer dot what? How do we append it?
Append.
Append, yeah, append. Append C. Okay, so answer dot append C, you can write it as this. Answer plus equals C, yeah? We talked about that before, okay? Or alternatively, you can write this. Answer plus equal parentheses. Look, parentheses, C, comma. This means that's a tuple, okay? It's the same. So you can put a tuple, put the content of a tuple into the list. Okay, this is also okay.
That looks weird.
Weird, okay? So why there's a comma, okay? It's very strange because this is like a number, right? But this is a tuple. Tuple. A tuple with only single element. That's why we put the comma. Yeah, comma. How do you call this? Comma. In to say this is a tuple, not a number, right? Okay, now look, if C is big, if C is smaller than E, right? If it's still in the range, then I can Q. Okay, so if this number is C, it's the rightmost digit? It's the digit at once? For example, 1, 2, 3. What's this number?
Modulus 10.
Okay, so let's say L equals C modulus 10, and then I want to append the next number, which is what? In the Q. Look, this is 1, 2, 3, and what's next? It's 1, 2, 3, 4. Yeah. Yeah. So I need to. How can I get this number from this number? I need to multiply this by. What?
10.
10 and plus this number plus 1, right? So this is C times 10 plus L plus 1, right? Okay? Yeah? And then return answer. Okay, there's one problem here, which is if the last digit is 9, do we have to append it?
No.
Yeah? Because if last digit is 9, let's say stop. Yeah, so we have to say
unless if you can say 910.
Well done. Okay, but no, if L not equals right 9, then we can append. Yeah, append. Okay, that's the breadth search. Okay, and then let's write the breadth search. Okay, it should be very easy. Okay, answer we keep this answer, but instead of Q, we use the recursion or the stack. Right? We ask the computer to maintain the stack for us. That's why we use the recursion. So define breadth search, and let's say the current number is C, okay? If C is bigger than s smaller than e, then we append it, yeah? We append this number, okay? Append C, okay? Append C. Yeah? Okay, because this answer is non-local to this function, we have to declare as non-local answer. Now look, if C is bigger than the upper bound, right? If C is bigger than upper bound, and I just don't need to continue return, right? Make sense? Yeah.
Is that nothing?
Yeah. And then I need to the last digit is what? C modulus 10, right?
Yeah.
And what's the next number? I can say therefore if L not this is the same, yeah, not equals 9, then I can therefore search C times 10 plus L plus 1, right? Let's say it's next number, right? Because this is 1, 2, 3. 1, 2, 3 times 10 plus 3 plus 1 is 1, 2, 3, 4. Make sense? Yeah? I know what's next. What's next? So at the beginning, what should we do now? So this is therefore search, and we should therefore search what? How many possibilities for the first digit?
None.
So let's say for I in range 1 to 10, and therefore search I, right? And then I have this answer, because I can return answer. Yeah, return answer. Or return sorted answer if you want to have it increasing, yeah, from 1, 2, 3 if increasing. Make sense? Yeah? Okay? Okay, so this is therefore search. So do we actually know what kind of, so do you have actually think about how many possibilities are there? You know, because we always stop at, is there upper limit for how many numbers, how many kinds of these numbers are there? So you have to tell me, first, is it unlimited or is it, there's just a total number? You know, we can find it out.
Limited.
Limited. Why is that limited?
Because I don't know how to explain.
Can you,
Because I think because they're not really a lot of numbers.
Okay, because every time you no matter what kind of number you pick, you always end at which number?
1, 2, 3, 4, 5, 6, 7, 8, 9.
No matter which digit you pick, you always, the last digit always, the maximum you can go is what? Which number? 9, that's it. Yeah, so that's limited, right? So let's say, if it's limited, what does it mean? If they are previous, the default search, preferred search, what's the time complexity if it's a limited scope? How many? Yeah, because look, it's constant time, right? Because they're only limited, right? It's constant. Make sense? No matter the start and end, the given inputs, there's only the limited number of these numbers. I give you one example. Okay, so can you give me the number start with 1?
Yeah, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3.
Okay, and then tier 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah?
1, 2, 3, 4, 5, 6, 7, 8, 9 is the biggest.
Yeah. How many numbers are there?
You just did
How many? How many? Count. How many?
1, 2, 3, 4.
Do you have to actually count? The last number is what?
9.
9, yeah. Okay, so start with 2. How many?
2, 3, 2, 3, 4, 2, 3, 5.
Okay, so how many?
8,
Okay. And then 3. Do you need to count?
7,
6,
5.
4, 3, 2, 1. 1 is what? 9, right? This is what? 8. 8, 9, right? Yeah? Make sense? So how many numbers all together? How many all numbers together? These numbers added together, right?
45.
Wow, that was quick. Yeah, how do you know it's 45?
Because
Yeah, 45. That's only the 45 numbers. Because what? How do you get this number? 1 plus 2 plus 9. How do you know? What's the sum? What's the sum of the first n natural number? Remember, we talked about this. Sum of the first n numbers. Yeah, sum of the first n. So let's say sum n. Yeah, I equals 1 to n sum I, okay? Sum I. That equals what? The last number plus the first number times how many numbers are there divided by 2. So if we plug in the 9, so the number will be what? 9 plus 1 times 9 divided by 2, that's 45. If we plug in 100, what's the number? 1 plus 2 plus 100. 100.
50.
Yeah, 100 plus 1 times 100 divided by 2, that is 50, 50. You see, that's the equation, yeah? First n integer, start from 1. N plus 1 times n divided by 2, okay? Okay, so so we have only 45 numbers here, right? So we have only 45 numbers. So we can actually do this, yeah? Because we can actually do this. Look, we can actually do this s equals 1 to, let's ignore the 0, right? And we can do this. We can start with each number, and then we can try the brute forcing to all the digits on the right, right? Yeah, and we can find if it's the range. So we can do this answer equal. That's a string, yeah. That's a string. For I in range what? Range
1 to 9.
1.
No, 1 to 10.
So let's start with the index. Well, index is what? 0 to 10, right? To 10. Yeah, to 10. So let's start with, and then let's start from the left, I with the left index, and the right index will be for j in range I plus 1, right? I plus 1 to 10. And then this number is what? Is s I to j, right? I to j. And we convert it to integer. If s smaller than equal e, c smaller than equal e, then we can just answer the append c. Okay? Then we can just do this and then return sorted answer. Sorted answer. Yeah, if you want to, if we don't provide the sorted, it could be out of order, right? Out of order. For I in range actually is 9. Okay, it's not 10 because there are only 9 numbers here. So that's 9. The index will be from 0 to 8. This I is the left index, so I is the index for the left. For example, if I equals the 0, 1, 2, 3 here, right? And then j will be the index from I plus 1 to the n, right? So there will be 4, 45, 456, yeah, this kind of thing. And then c will be converted from a string to the integer, and then we check if it's in the range. Then if it's not in the range, then we append it, right? What's the time complexity for this one? What's the time complexity one for this one? What's the time complexity? Look at this one. What's the time complexity? How many iterations? Where's the n? Which one is that? Come on. There are 9 iterations here. And
1.
Oh, 1. And they are at most, right? You can say it's at most 9 iterations. So they are at most here, as we said, look, 45.
Mm-hmm.
So it's actually 045. So which is
01.
01, yeah? Because no matter this argument doesn't depend on S and E, right? Look, these two are determined. These two are fixed, no matter the value S or E change. It doesn't change, right? Yeah? Mm-hmm. S a million, E a trillion. These two are not effective, right? Am I right?
Mm-hmm.
Okay, so the only thing makes a difference is this, by checking the range, right? Right? But this is the loop. The number of times this loop executed does not depend on the value of S and E. So the time complexity is 045. The space complexity, okay, we're quite tricky. Space complexity. How many numbers can we store in these answers? Maximum.
45.
Yeah, so which is
01.
01. Yeah, well done. Okay. Okay, so to sum up, the previous breadth search, depth search is also 01, right? Yeah? Yeah, you can't find more than that, right? Because we always stop at number 9, and when we expand the next kit, we always have the +1 at the end, right? Yeah, the next digit. So the search space, is not, it's limited. It's not unbounded. Okay, it's limited. It's limited by 045. So all the implementation we talk about today is O1, constant time and constant space. Any questions so far?
Nope.
Okay. Bye bye.
Bye bye. Bye bye.
Okay.